Thank you
Please,
very much. Thank you very much, Mr. Choka, for the introduction. My pleasure to present one study of our project, detection and localization of food pathology in cattle. If we have a look on the paper from Genoff and Weir, we can lameness in cattle we can categorize it in two main categories. The first one is distal lameness, and I'll show you an example for this case. So mainly in the distal lameness, the pathology are located in the digit area, and typically, as we see in this video, the cows, the lame cows, has a short time of weight bearing on the affected limb compared to the non-affected limb, and the swing phase of the affected is much longer as compared to the healthy limb. This cows typically has distal lameness. The second type of lameness, it is a proximal lameness, so the pathology mainly located in the proximal area of the limb. And if I show you this example, so the swing face in this case is stiff, and cows scratching the foot over the ground. So this is typically in cows with pathology associated with lesion in the proximal area of the limb. So quite different between the both cases, but some cases we have the mixed lameness as the distal and the proximal lameness together present. So the aims of this study were to evaluate the suitability of cow pedogram to detect the pathology located at the hind limbs in dairy cows, and secondly to investigate if the cow pedogram can differentiate between proximal and distal limb pathology. Before I start my presentation, I would just a short explanation about the cow pedogram. It is the principle of the cow pedogram is similar to the electrocardiography regarding the measuring the activity of the hair. And I can show you a figure about the gait, one gait cycle. I mean one stride in healthy non-lame cows. So we have here two peaks, the foot load and the toe off, and the maximum peak when the claw contacts the ground is the foot load, and the maximum peak when the claw leaves the ground is the toe off. And between the two following foot load, we have the gait cycle duration or the stride duration in second. And we have here the stance phase duration and swing phase duration. And the swing phase duration, we calculated it as a percentage value to the Gait cycle duration, and is the time point when the claw contacts the ground. And we have the swing phase duration when the claw non-contacting the ground. So the study performed at the ruminant clinic in Bern, Switzerland. And for the study design, we have two groups. The first one is the control group. Those cows, non-lame cows, and also these cows clinically examined and showed no any signs of the pathology. This is the first group, Group C, and we have Group P, pathology group, and this group we classified them to two groups. The first one is the distal group with pathology located in the distal area until the fetlock, including the lock joint. And we have the proximal pathology is proximal to the foot joint. So also we perform the Gait score. If we have a look on the Gait score in the both groups, we have here in the red color, we have the range of the locomotion score. And it's very important to see that we have here, according to the system by flower and where we have non-lame cows in the both groups. So the locomotion score is not sensitive method to detect cows, even this cows has a pathology. So that's the idea behind this classification, to have an objective method to detect mainly non-lame cows, but they have pathology. So the clinical cases were examined to the clinical procedure, routine clinical procedure at the clinic, and if indicated, we performed radiographic and ultrasonographic examination to give us the defined pathology. And the defined pathology, we classified them in two categories. The first one is the distal group, as I said, until with the fetlock joint. We have different pathologies, more of those pathology, but all of them included in the digit area. And we have here the pathology included in the proximal area of the fetlock joint. And this classification were used as the gold standard for the group allocation. For the statistical analysis, we determine the difference across the limbs. We have unilateral cows with foot pathology. We determine the difference between the left and right limbs as absolute difference. And we use it the one-way ANOVA to determine the difference among the groups, and the p-value adjusted to Banfaroni, and we use it also the rock analysis to determine the performance of the cow pedogram. If we compare the control group, the control group have no any signs of limb pathology compared to the pathology group. All the Gait cycle variable were significantly higher in the pathology group as compared to the control group. I can give here an example for the stance phase. If we set the cutoff value at about 2%, we have a sensitivity of 97% and specificity of 100% to classify a control group from the pathology group. And the second example, the second case is compare the control group to the distal group. All the variables were significantly different. We have higher value of the difference across the limbs in the control group comparing to the distal group. And if we have a look also, if we set the same cutoff value of the stance phase, we have sensitivity and specificity 100%. For the third part of the analysis, if we compare the distal group to the proximal group, So the difference across the limb for only for the foot load was significantly different. So the difference across the limb for the foot load in the distal group was significantly higher, so that the cows with distal lameness has less kinematic force compared to the group with proximal pathology. But the performance of the cow pedogram was poor to differentiate between the distal and proximal group. So that in this case, we cannot set a cutoff value to differentiate the distal from the proximal group. And this is an example for the foot load. We see this, the performance of the rock analysis was poor. So cow pedogram is an objective tool with high accuracy to detect unilateral cows with limb pathology. Even these cows, as we show in the at the beginning, has no clinical signs of lameness. But the cow pedogram, all the variables were not suitable to differentiate between proximal and distal located pathology. Finally, I would like to thank you, and I am happy to answer your question.
Thank you very much.